Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of the screen, wherever your Zoom controls are. You should find a Q&A button. Click on that Q&A button, type in your question, hit submit, and I'll get to those questions at the end of the session. If you're joining us on YouTube and you're live, just type into the live chat and feel free to use that and just type in your question there, and I'll get to those at the end of the session as well. So my name's Jason Gabrenas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 8 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple of years as a diagnostic sales rep with Snap-on. So I had 30 different Snap-on franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So I was a tech at a Subaru dealership. And over time, I guess, just kind of became the default diagnostic guy in the shop, right? So I always had the drivability problems, the intermittent problems, the weird wiring problems always seemed to end up in my bag. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird problems that would come in. And before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is component testing. We're keeping with our component testing theme we've been doing for the last few months. And this time it is gasoline direct injection. So it's a little different than what we're used to on our classic systems, our older multi-port injection systems, so to speak. There's some differences, but there's some commonality in there as well. So why are manufacturers going to this gasoline direct injection, or GDI as we call it? So gasoline direct injection does offer the following benefits to both the manufacturer and the consumer. Increased fuel economy is one of them, because the fuel charge can be much smaller, it can be much more precise. So it allows us to use less fuel per combustion event. Also, due to that, we can increase the power while also using a smaller displacement engine. You see a lot of those 4-cylinder turbocharged engines out there now, that whereas a few years ago, maybe 10 years ago, maybe you might have found maybe a 6-cylinder in there or something like that. So we're able to get more power out of a smaller engine package. Also gives us lower vehicle CO2 emissions, which is always good. Lower emissions is what they're going for. And then also improved vehicle responsiveness. We can increase the torque on the, just as the throttle gets in, it gives us a better throttle response because of how we can meter that fuel more accurately. So let's think about the differences between our multi-port injection and the gasoline direct injection. So if we think about multi-port injection, that is a relatively low pressure compared to GDI anyway. It's typically about 40 to 60 PSI. It's injected right in the intake runner usually, right? So multi-port is going to inject in that intake runner, then it goes down through the valves and mixes with the air that way. Also, the injectors themselves are pretty low voltage, usually run at system voltage at least to start. And then, on the spike at the end of the injection pattern, sometimes that can go up to almost 100 volts. But as far as input wise, we're looking at system voltage, just whatever our alternator is putting out, 14.4 or what have you, with that system. So with GDI, it is a high pressure system. So it uses a high pressure fuel pump, and it ranges anywhere from 100 to 3,000-ish or more PSI, depending on how the system's designed and what the manufacturer wants it to do. But it can be anywhere in the much higher pressure. So we do also have to be careful when we're working around gasoline direct injection, because it is much higher pressure. And also, instead of being injected in the intake, it's injected directly into the cylinder. There's a couple different ways that we'll do that, and we talk about that in a little bit. And also the injectors are high voltage. All right. And if you were here for that video right at the very beginning, there's 65 volts on that Ford. A couple other vehicles we're going to look at tonight could be 140 and more voltage going into that injector. So you want to be careful of high voltage as well in those systems. So a couple of things you want to look out for as far as safety wise, right? So let's just say for an example, on a Camry, right? Camry has high pressure injection. So 350 PSI, usually they say about at idle. And then it can be anywhere from 290 to 2,900 PSI as the full operating range of that system. So that's pretty high injectors, right? So let's talk about the overview and how it's laid out. As we said, It's very similar to the standard multi-port injection that we've been used to for however long it's been out, but there are a couple differences. So it just a little line drawing example here. We have the fuel pump inside the fuel tank, right? And then it goes out from there, and the line goes out under a low pressure. So it's a standard fuel pump. Could be a brushless fuel pump as well, but it's still a low pressure fuel pump in that instance. Goes into the system, and then this high pressure pump right here, which we'll talk a little more in detail in a little bit, runs off the camshaft. So that is increases the pressure going into the line. So it goes into the line, and then it sprays through the high pressure injectors, and then anything left over will come back and able to recirculate that way. So it's very similar to the types of systems we're used to. It's just at a higher pressure and a higher voltage. And they operate a little bit differently, the injectors and the fuel pumps and such. So we think about how we're distributing the fuel into the cylinder. There's really two ways that manufacturers do this. We either have a homogeneous charge or a stratified charge. So a homogeneous charge is going to have evenly mixed air and fuel. So we try to get to that stoichiometric air-fuel ratio, but it's going to be evenly mixed. So fuel is to do this, the fuel is injected at the beginning of the intake stroke. So as it's starting to take the air in, it'll inject into the cylinder. So it'll be able to mix with the air and swirl as it's also being compressed again. This does offer a slight efficiency increase and a power increase over traditional multi-port injection. So that's one way to do it. And then the stratified charge sprays more fuel near the spark plug. So it's going to be more rich near the ignition source, and then it'll get lean the further out it goes. So it's a stratification or a gradient of fuel. So you have more fuel near the spark plug, less fuel further away from the spark plug. And when they do that, generally speaking, the fuel is going to be injected at the end of the compression stroke. So just as that piston's coming up, just as that spark plug's ready to fire, then it'll inject the fuel. So in this case, less fuel is also injected per event as well, because we don't need nearly as much. It's just going to do a little squirt right in front of the spark plug and allows it to then combust. They can also vary the fuel charge to change the torque output. So if we put more or less fuel in there, it can change how the vehicle responds torque-wise to that system as well. So there's also 3 injection modes. So we talked about the different injection types. Now we can talk about the injection modes. There's 3 of them. We're only going to talk about 2 of them because one of them is only used on like one engine. So we don't need to get into that. But we have wall guided and spray guided is what we're going to talk about. So wall guided, generally, it doesn't always happen, but majority of the time, the injector is going to be far away from the spark plug, maybe in the side of the combustion chamber. And then the fuel is injected into a cavity in the piston in that case. So we see this cavity right here. It's on a Ford EcoBoost. And we can see there's the little cavity there. And so the injector, once this is where it needs to be, the injector will spray into this little divot right there. And then it will guide it up to the spark plug. So the wall of this cavity guides it to the spark plug. And then in other cases, we may have a spray guided. So in this case, the injector would be close to the spark plug. We can see on this BMW, there's the injector there. There's the spark plug right there. You can't get much closer than that. And then the fuel is injected right before ignition, as we said. So that'd be more of that stratified charge right there. Squirts it right next to the ignition source, so it makes it pretty darn efficient. And just some graphics about the difference in our homogeneous and stratified charge operation. So on the homogeneous, as we said, it goes on the intake stroke, allows that swirl to come in, and we get that swirl to build up as it compresses. And then on the stratified charge, it has that compression stroke injection, and we have more fuel closer to the spark plug as it comes up, right? So give you a little visual as to what we just talked about. All right, so GDI issues. Due to the design that we've just been talking about, spraying into the cylinder, we do have some issues, and I'm sure you can probably guess what the most common issue is with GDI is, well, it's spraying right into the cylinder. You'll notice that my intake's over here, and my valves are over there. So it's in the middle of the valves. It's in between the valves. It's not squirting on the valves. Like common port injection, where it sprays basically onto the back of the valve as it mixes the air, that allows us to clean the valve. Whereas if we're going through this is a wall guided design, right? So it comes through the side and hits that wall. Well, we're not hitting the back of that valve at all. It's just the air comes in, and then it's spraying into the cylinder. And we don't have any way to clean off the back of that valve. So in that case, we can get some carbon buildup, right? And that seems to be one of the biggest struggles with the GDI engines is all that carbon buildup. And where does the carbon come from? A lot of it comes from the breather system, PCV system. So it ventilates out. I have oil in my air that comes out, and then it goes back and gets reburned. Well, it goes in through the intake manifold. So the intake manifold can get all gunked up, and everything gets all gunked up. So you can see that's pretty bad right there on those valves. That could cause a drivability problem. It builds up enough that valve's not even going to close, right? So it's going to hold it open, and then I could have misfire problems, right? So big problems in there. There's ways to clean them now. There's plenty of ways to clean them now. I know a lot of companies have come up with that, but some of the manufacturers have come up with a few different ways to combat this as well. I know Subaru, when they first started doing this, they actually have a patent on a reed valve that goes in the breather. So the breather at the top of the valve cover, 2 valve covers, right? So it's got a breather in there, and it's got a little reed valve. So that little reed valve is just enough tension where the air can get by it. But as the air goes out, it's going to wipe the oil out of the air. The oil will stick to that reed valve, and then it goes back in the case there, inside the valve cover, right? So it's trying to wipe out as much of that oil as possible. Now, I'm sure some still gets through, but it's a way to mitigate it. And then as far as Toyota's concerned, Toyota came up with a different way of doing that. It's a little more pricey, I think, but their D4S system, they call it, has both a direct injector, which would be right down here, and also a regular multiport injector. So if you have a 4-cylinder engine on one of these vehicles, you got 8 injectors. You have 4 high pressure direct injectors and 4 lower pressure regular multiport injectors, right? So there's a difference in a few different ways of attacking that back of the valve problem. There's also, I read on this D4S system, they made a couple improvements along the way, and the injectors are actually able to clean themselves as well at an idle. It'll spray around and allow itself to clean the carbon off the injector as well. So lots of thinking, a lot of engineering involved just to get that little extra increase in power and that little extra increase in gas mileage. Okay, fair enough. But yeah, there's plenty of ways to get around it, I guess, nowadays. So that's kind of a neat little engineering trick. So let's start at the top, or where we would begin with our direct injection part of the engine. Because as I said, we have a regular fuel pump in the tank by and large. It's going to send lower pressure out through lower pressure lines until it gets to that high pressure fuel pump. So this is just an example on a Toyota, but I've looked at a lot of these different systems. A lot of companies use the same type of pump. It's a Bosch. There's a Bosch version and a Delphi version, and they're pretty similar. They got 2 wires there. It's for like a bleed valve. We'll look a little bit more in detail on that in a second. There's a roller lifter that runs off the camshaft, and then we have some gaskets and brackets and things like that, and then our high pressure line. So what it does is, as I said, it runs off the back of the camshaft. So there's this lobe here, looks like a rounded square. So as that goes around, when it's flat, it's not compressing. When the corner goes up, it will push up on that lifter and will compress the spring, which will compress a piston inside the pump, which will increase the pressure of the fuel. And then that's how we can get our over 1,000 PSI out the back end if we need it. So there's just a cross section of this. This is the Delphi one. So we have, it's a mechanical design, right? So we have that lifter is going to be in here. It's going to lift the plunger. It's going to go up and down, and it's going to compress that fuel as it goes out the side. The only electrical piece on this is going to be this spill valve. So it's a little valve that opens and closes and controls the pressure and the volume going through the pump. So it either opens and closes, to bypass more or less fuel. So that's a fairly simple thing to test. If you could have an electrical failure, resistance test generally, and it's a pulse width modulated signal. So we could see that. Otherwise, we could have a mechanical failure, maybe on the camshaft itself, the lifter, the spring here, the plunger, any of the mechanical pieces in there. And then we just have a massive pressure drop in the system if that happened, right? So that's our high pressure fuel pump. And then we have our fuel injectors. There's 2 really main types that are used out there as far as fuel injectors. So we have on the left here is our standard multi-port fuel injector top feed. Pretty common out there. A lot of cars use this. Use a top feed or a side feed. Now it has the coil of the fuel comes in the top, has the coil around there, and then the pintle moves up and down to open and close and allows fuel to spray, right? So that's a fairly common type that's out there. And then over here on the right-hand side is one of our 2 types of gasoline direct injectors. So it looks an awful lot like this one, but it's got a longer pintle here, and it's actually able to open and close quite rapidly as well. With the higher pressure, it also needs to be able to overcome that higher pressure as well. So you see cross-section wise, they look fairly similar. They got the return spring and this long pintle here, which also has the effect of getting it into the cylinder, right? We need to get it in the cylinder all the way instead of just pushing it into the intake manifold. So it does need to have a longer neck regardless, and it does look different if we were to use a scope. So here's an example on one of these injectors on a Subaru. That looks very similar to the Ford that I had in the intro video as well. So on this system, we have a power side and we have a control side. So we see on this case, it's 65 volts, goes up to about 65 volts when it opens. And then we see the amperage goes up as well. The control side goes up. And then we can see how it kind of drops off a little bit, drops off to about, well, system voltage. So we have a big spike at the beginning to get it open. And then once it is open, we have the current ramp go up, and then it levels off a bit. And then you can see it drops even once more. It drops my amperage again, and it gets down to where I'm pulse width modulating the pintle open. So it opens for, it's not that long of a time either. It's about 2 milliseconds, right? So it's about 1.5 here and about 3.5 there. So that's about 2 milliseconds, right? So that's at an idle. So we can see how it opens, and then it pulse width modulates it to keep it open, and then it closes again over there. So we can see all that in the pattern. So it looks a little different because we got an open side and a closed side, or open side and a control side. And then we have the amperage that flows through as well. So that's all 3 on 1 channel. So that's that style. And like I said, seems to be around about maybe 65 volts, somewhere in that nature is where we're going to peak out on those. So it's not nearly as high a voltage as, say, a piezoelectric fuel injector. I see I did just get a question on that. So hopefully this will answer your question, or we'll answer it in a few minutes. So this is, you'll notice they're a lot longer. Right? It's going to go way into the chamber, way into the combustion chamber there. It's usually probably buried pretty good. High pressure fuel comes in, and then the actual body here. And then we have the piezoelectric actuator. You might have heard that it's called the piezo stack. And then we have a hydraulic amplifier, which just allows us to amplify the pressure. And then the nozzle that comes out the end. So we once again have a pintle in here, but it is operated by this piezo stack. So piezoelectric functions in 2 ways. We can either move the stack, and if we move the stack, it'll generate an electric voltage and send an output voltage. Your knock sensor works like that. So oftentimes those will be piezoelectric elements. And when they hear the knocking and the tapping in the engine, the vibration will cause that stack of wafers to shake and move, and then it generates a voltage and it sends it out to the computer. If we apply voltage, they'll do the opposite. So they'll move when we apply voltage. So if they move on their own, they create voltage. If a voltage is applied to it, then it will move itself. So we have a casing, we have a top and a bottom, voltage comes in. When we add voltage to that, they squish up and down, and it allows it to move that pintle up and down as well. So there's a stack there, and there's my amplifier, and there's how it would open and close. And these things can open very, very fast in the matter of a few microseconds. So when the electricity applied to the piezo stack cuts off, though, the spring closes the pintle. So it's mechanically closed and electrically open. But they can use that to their advantage and open that pintle very, very quickly. So they're pretty long. They're pretty easy to tell when it's a piezoelectric type versus the other type there. But if we looked at the voltage or the circuit, the wiring diagram, we see we got 6 injectors here. It's on a BMW. We got a common power. They all get fed power on this white line. And then the control side is going to be on this brown wire in this case. And it's going to just it's labeled as injector 3 signal on both on this one. But this is power, and this is going to be the control side. So if we wanted to look at our guided component test information on this. So here's how these piezoelectric injectors operate. So power supplied to the injectors from the PCM. PCM supplies high voltage to the piezoelectric injectors of about 140 volts and also controls the ground side of these direct injectors. Computer supplies voltage to bank 1, so injectors 1 through 3, and then controls the ground side of the specific injector. Same is true for bank 2 on injectors 4 to 6. The voltage on the ground side is influenced by the supply voltage. This is why you will see 2 high voltage waveforms, which look like the power to the injectors, and then low voltage only once when the injector is turned on. So if you're watching on a scope on one injector, you'll see sometimes you'll get amperage, sometimes you don't. If you don't see the amperage, it didn't open. If you do see the amperage, it did open, because it will supply, and you'll get this kind of like a shadow almost of the other injectors when they're opening. Let's see. This is why you'll see 2 high voltage waveforms. Let's see. The injector is only turned on when the voltage is pulled down low. So we'll see a low pull as well. The other high voltage pulses on the control side should be ignored, as they do not affect the injector operation. When voltage is applied across the piezoelectric element is squeezed. This will cause the element to expand, pushing the injector pintle off of its seat. The injector will continue to inject fuel until the current reverses and pull the injector back to its seat, and the fuel injection is forced closed. So we also, if we do a current ramp, which you're going to see in a second, you get a positive and a negative current as well. The PCM uses sensor inputs to calculate injector on time. Injector on time at idle on a fully warmed up engine is typically 675 to 975 microseconds. So I said they're very, very fast when they open and close. 675 to 975 millionths of a second, right? Microseconds is a millionth of a second. At snap, the injector on time increases to about 1.5 milliseconds, which would be kind of short for a multi-port injector, but not out of the realm of possibility. Hard snap acceleration, there may be a double injector pulse. The first one short, about 500 microseconds, and the longer on time over 1.5 milliseconds. When driving under heavy load, the piezo injectors may even enter a multi-striking mode, where it will turn the injector on and off several times in one cycle. And you can actually see that on the screen as well. So it gives us our points to hook up. And let's go into a test real quick. This is a signature test. Just wanted to point this out for you. The voltage supplied is up to 140 volts at 10 amps and can peak up to 220 volts. That'll hurt a lot. So don't make contact with the fuel injector harness, ECM, or fuel injectors while the ignition is on a on or run position. They also suggest using certified insulated gloves rated to 1,000 volts. Recommend to wait about 5 minutes after the key is turned off to allow the capacitors to bleed off as well. So that's how we get up to that 140 volts, is by having capacitors inside the ECM that build up the voltage, right? If we were going to hook this up, though, we would see yellow wire, channel 1 is going to go to piezo injector power side, black will go to ground, and green will go to piezo injector control side. And then it gives us the same basic information we have down here. If there's a fault in the high pressure system, then the injector will open on the intake stroke as a fail-safe measure. So it goes from a stratified charge to that homogeneous charge, because there will be not enough fuel pressure to spray fuel into the combustion chamber on the power stroke. Because on the power stroke, it's going to be a lot more pressure in there. Fuel pressure will be too low to overpower the compression in the cylinder, like I just said. Right. So we have that, and if we were to test it, it's going to look something like this. We saw this. It looks a lot different than that other injector. So we have the power side, which is the yellow, channel 1, and then the control side is green. We see we have a positive and a negative. So that's opening and that's closing on the circuit there. So we'll always see the power flowing through, but see how it opens at the same time the power goes up, closes same time power goes down. Right? So it's open and closed side, and we have a little level in the middle where it's flat. If we want to enter a multi-strike mode, you'll see one after the other, rapid succession, open, close, open, close, open, close. So that's able to strike multiple times under a load every time it fires. And then if we were to do a current ramp test, it's going to look very similar to this green line, right? So where we have the control side open and close, we also have a positive and a negative amperage going through there as well. So we'll see an upward spike on the amperage, and then a downward spike on the amperage when it closes. So they should pretty well mirror each other when we're testing. If we don't get this type of pattern, then we have a problem inside, right? So let's go do a couple more, let's look a little bit more information on the injection systems as far as what we would see on our scan tool, right? So I have a 2017 Mercedes C-Class loaded, C300. Guided component test would be a good place to go. So if you have a Snap-on tool with a scope in it, it's going to have guided component tests in there. And guided component tests is our database of over 5 million guided tests, vehicle-specific tests. So I'm going to pop into this Mercedes and see what we can look at. Engine system is where our fuel is, right? But we see other systems listed there. There's 7 different systems on this car. If I go into engine, here's all the components or subsystems on this Mercedes we have information to test. So if we want to go to fuel system, we'll take a look at the different things in the fuel system. So first, let's look at that fuel injector and see what type we have. So we can go into component information. And this is a piezo electric injector as well, just like that BMW we were just looking at. And also, hey, it provides about 140 volts. So it looks like they have the same manufacturer of fuel injectors as well, right? 675 to 975 microseconds, can open up to about 1.5 milliseconds as well. Gives us our pinout on our ECM if we were going to test it there, or also gives us our pin assignments on our actual fuel injectors themselves as well. Also, tech note, the injector tip is fragile. Follow manufacturer procedures for installing back in the combustion chamber, and don't allow any dirt to enter the injection system either, because that would be bad as well. All right, so there's our component information. We can do a resistance test. Let's see how much resistance that can give us. So we also get a warning, don't get electrocuted, 140 to 220 volts. Typical resistance on a cool engine on a piezoelectric is 400,000 to 600,000 ohms. That's pretty high resistance. On a fully warmed up engine, after a hot soak, typical resistance can be as low as 150,000 to 200,000 ohms, which is still pretty high, right? If you're dealing with a regular multi-port injector, 14, 15 ohms, something like that is what I see oftentimes. So it just gives you a few different resistance tests you could do on that. Signature test is going to give us that same look signature that we were looking at earlier. We have the power side and we have the control side, open, close, and then open, close right there. Right? That information. And then as far as the current ramp, same thing we just looked at because it's the same type of injector. Going to use our low amp probe, and we're going to go in and check, and we'll see a positive and a negative. It does give us this information though as well. So it'll flow first positive to open the injector, then negative to close the injector, as we said. Total current in amps from peak to peak should be about 8.5 to 9.5 amps at idle. So from there to there should be about 8.5 to 9.5 amps. If it's more than that, or it's less than that, we could have a problem. If I have like 2 amps, that would be bad. If I had 20 amps, that would be bad, right? So if you have view meter on any of those, it'll set it right up for us. So that's the fuel injector. How about the fuel pump? What do we got for a fuel pump on this car? If I go into component information, it's an electric pump responsible for pressurizing the fuel system, of course. And this is talking about the low pressure fuel pump right there. And then we also have the high pressure fuel pump information there. And if I look on this, it gives me my pin assignment. There's a control module for this fuel pump. And this is a brushless fuel pump. How do I know it's a brushless fuel pump? Because it has those 3 phases. If you want to learn more about brushless fuel pumps, watch the fuel pump component test class that we did not too long ago, and it talks all about how those patterns look completely different and how they work as well. So we have our 3 phases and our ground. So that is a brushless fuel pump. High pressure fuel pump operates between 120 and 200 bar, or 1740 to 2900 psi. This is a very high pressure system. When the engine is shut off, the fuel pressure can rise up to 3,916 psi or so, give or take, because they measure it in bar and do the conversion, right? So high pressure can be very high pressure on this car. Remember how I said up over 3,000, almost 4,000 psi when it's off. So definitely be careful of that. Definitely be careful of the voltage. All right, so we could do a voltage test on that. It's going to just show us the different patterns there. And then current ramp tests would be for the a regular fuel pump there. And then it's fuel rail pressure temperature sensor as well in there. So that is a 4-wire sensor. It's got fuel temperature and pressure in the same unit. So that's something that could fail as well. And that is going to be just a different varying voltage as we go there. So let's say I tested this fuel injector, and then I need to replace this fuel injector. Well, we're probably going to have to use our scanner. Actually, a lot of vehicles, not just direct injection, a lot of direct injection vehicles, but a lot of vehicles in general now, when you replace a fuel injector, you need to code the fuel injector to the vehicle. So let's see how we would do this on this 2017 Mercedes. So the easiest way to access this test, now all Snap-on scan tools anyways, are going to have the same coverage for vehicles, right? So if I have the same software version up to date, I'm going to cover the same amount of vehicles, same amount of systems, same amount of tests. It's just on some of the tools, they make it a little easier to get to, right? So if I have an intelligent diagnostics tool with an up-to-date subscription or data plan, I will have access to the service resets and relearns. Also, if I have a up-to-date Veris Edge would also offer me that. So service resets and relearns is a quick link to get into any of the resets, relearns, things of that nature on a vehicle. So in this case, they're set up by job. All right, so we have our maintenance stuff on the top, and then it's by engine and so on and so forth. So in this case, let's say I replaced a fuel injector. Now, if I didn't have this quick list, I could also go into the engine module and find it in there. All right, so it's going to give me some top repairs graphs, some bulletins. Looks like there's 5 TSBs on that. And then functional resets and calibrations. I know I'm in simulator mode. So it's going to ask me what controller. There we go. And then it's called the injector quantity adjustment. Now let's learn a little bit more about this injector by going into repair information. So if I have Shopkey or Mitchell on this tool, I can also go into repair information and it will link me directly to my information for this injector repair. Now, if I don't have Mitchell or Shopkey, or I don't have this tool, I could still look it up and still find the information from the manufacturer wherever you happen to get your repair information. So once it does that, it's going to pass the vehicle through, it's going to pass the job through, and then I got my search results, right? So I get some fuel injector stuff over here and fuel injection with real world results over here. So I'm going to go fuel injector replace. My TSBs, top repairs, etc. There's my guided component testing we were looking at. Let's go into remove and replace. So removal and replacement is going to show us in identifying the injector, how that works. It's going to go through a bunch of information about that. It's going to go through, here's what the injector looks like, right? It's that piezo electric thing. If I go through, it's going to say install in the reverse order. And then it says store injector quantity compensation coding in the control unit. So that is that injector compensation coding, injector quantity adjustment we were talking about there. So we have to make sure we program that. And then we also have a puller to get these out because oftentimes they're in there really tight. And then also that's an assembly tool for putting new seals on as well. So there's lots of information there as to how that works, how that operates, how it fixes it. We want to pop in the wiring diagrams and see how that works as well. I can come in here. First one's going to give me a injection valve. This one gives me the actual injectors down here. Now on our wiring diagrams, you'll notice it drops me off on the proper panel where my injector is. Also pre-highlights the wires for me. If I want to hide the other wires just to see those wires, I can do so. Zoom in a little bit. And we'll see they call on this car, they call it injector low and injector high. All right, oops, I accidentally hit the ECM by accident. So injector low and injector high will be the open and the close, or the power and the control circuit there as well. So we can see that on the wiring diagram. So let's go into back to the scanner and back to our injection quantity adjustment. So if I click on that, yep, I'm in simulator mode, I know. It says before continuing, make sure key is on, engine off. Don't want to do this while it's running. When replacing an injector, it's essential to save the QR code of the new injector on the engine control unit. This process ensures that the necessary correction parameters for the injector will be recorded in the engine control unit. These correction parameters enable the engine control unit to meter the injection quantity precisely, because every injector is going to flow a little bit different. So I need to make sure I'm telling it what injector I'm using. So if I hit continue there, QR code of the injector consists of a 5-character number. This number is located on the body of the injector. So I'll hit continue. Then it'll show me what injector codes I have in the vehicle right now. And let's say I replace number 1, this one right here. I'll hit edit. and I can just type it in. So let's say 1, 2, 3, 4, 5, right? So it's a 5-digit number, 1, 2, 3, 4, 5, hit OK. There's the old ID, there's a new ID, make sure it's right, hit program, and we're done. Programming successful. All right, so we're all done. And there's my 1, 2, 3, 4, 5 on my injector right there, right? Pretty simple test, but you need to do that anytime you replace an injector on a lot of different vehicles. BMW's got it, diesel trucks, definitely on diesel trucks, we got a ton of those. But you want to be able to go through there. Now, that was through service resets, right? And you saw how easy that was to find. Now, if you didn't have service resets, that's okay. We can still go in the engine. It's going to tell me I'm in simulation mode again, because I am. And then all we would have to do is go into our functional tests inside the engine. And let's see, I believe that's an adaptations. Let's go into adaptations. And let's see. There we go. Injector quantity adjustment right there. So you have to find it on the list, but it is there. All right. So we have camshaft teach-in, throttle valve stops, coding, correction programming, fuel quantity, right? It's a whole lot of different functions to do on this vehicle. What if I wanted to do actuator tests, right? So there's a ton of actuator tests we can do on this Mercedes as well, right? So like, turn the coolant pump off, fuel pump on and off. That might be handy on this in order to diagnose some things. So if turn the fuel pump on or off, we can do that in there. Shut off the injectors individually. Those are in there as well. So a lot of helpful tests inside this inside the system there, and you have to use a scan tool in order to do that. Also note on Mercedes, just thought of this because of what we're doing right now. So on a Mercedes, you always want to stop communication before you back out of the car, because we could have problems with the car. So a few years ago, we built in the function where you need to turn the key off, turn the key on, cycle the key, and it checks to make sure the key was cycled in order to back out and close out, so we don't break any cars. We don't want to do that either. So back out of that and back here. And that is our class on gasoline direct injection. So hopefully we learned a few little tidbits out of that. Let's talk about what we're doing next week. Next week, we're getting into the EVAP system, and there's so much to talk about with the EVAP system. We need to take 2 classes to do it. So we're going to start with part 1 next week, which is going to be overview of system operation. And we're going to go through actually a real world case study. And how do you know not every EVAP code is a leak, right? Some people just kind of see EVAP and say, oh, it must be a leak. Not always the case. We can have electrical issues in the system as well. So we just got to make sure we think about that. We're going to talk about that next week as well. So if you want to join me 2 times, 6 and 9 Eastern, 5 and 8 Central, and so on and so forth. If you go to snapon.com/OT to register, you can join me on Zoom, or we will live stream the first class, 6 p.m. Eastern, to YouTube at our youtube.com/snapon-diagnostics. If you're watching on YouTube, thank you very much. Make sure you subscribe and hit that notification button so you'll get notifications anytime we go live or anytime we post other information. Also, class number 2 goes to my Facebook page as well. Also archived on YouTube, we have 24. Well, this will be number 25 as far as our live stream training. So we have ADAS, data bus testing, ignition testing, and all of our component testing classes we've done so far are all archived on YouTube as well. So if you go to youtube.com/snapon-diagnostics, there's a playlist for live training. All right, so now let's take a look at a few questions. I see I got some up on Zoom and I have some up on YouTube. So let me, before I do that, because I got a few I got to cover, let's also talk about my buddy Al. So Al helps me out every Tuesday, and then I help Al out on his classes Monday, Wednesday, and Thursday. So Al does tool-specific training. So on Mondays, it's Apollo, Wednesdays is Zeus, and Thursdays is Triton. So he goes through everything from, let's set up your Wi-Fi, make sure that works. Because Wi-Fi, a lot of things on a tool nowadays are dependent on Wi-Fi. So we want to make sure that's set up. We're going to set up a free Snap-on Cloud account as well, so you can upload your files and your pre-scans and post-scans and share them with your own customer. All the way through, let's walk code the completion through intelligent diagnostics, so we can see how intelligent diagnostics can help us save time there and diagnosing a vehicle. So the Apollo class is about an hour long, and then the Zeus and Triton are about 2 hours long. So in the middle of that, after that first hour, takes about a 5-minute break. and then come back and talk about guided component tests, scope, meter, all the different scope and meter functions with a few different examples of how and why you would use that. So it's a very thorough class. Al's been with us for over 30 years, came over with the scanner, the red brick there. So he knows an awful lot about Snap-on Diagnostics. So definitely a wealth of information there. Definitely make sure you check him out Monday, Wednesday, or Thursday, depending on what you got for a tool. So let's go to our questions now. I'm going to go to Zoom first. We have a couple here. Tom Spina, yes. So thank you, Tom, for that comment. And there are 2 classes on EVAP. So it'll be the next 2 Tuesdays will be EVAP classes. So class 1's next week. The week after that will be class number 2. So yeah, definitely 2 weeks in a row worth of EVAP because man, there's a lot to talk about there. There's a lot of pretty common codes on a car's EVAP there. All right, let's see what we have up on YouTube here. Let's see, Manny, Autotech, welcome. Thank you for joining. Thanks for checking in. Nicholas, thank you. Welcome from England. Let's see. So do you know another test to determine whether you're dealing with a piezoelectric type injector or a solenoid type injector other than measuring resistance? Well, I think we saw in that class that there's definitely a big difference in resistance for sure. But if you can't get to it, the current ramp looks different, right? So we have a positive current ramp on the solenoid type, and then we have positive negative on the current ramp. So that should be pretty easy to do. Also, we saw that the voltage patterns were different as well, or the manufacturer might tell you to as well. So I know that question came in a little before we talked about that. But that's okay. Let's see. Nicholas asked, when Snap-on courses in the UK? Well, Snap-on, I know, has their own training department over there in the UK. They have a bunch of actually very, very well-trained people over there. So I'm not sure. They used to do them in person all the time, and I know they've talked about doing them online over there as well. So definitely something to watch out for. I mean, just kind of look at the Snap-on Diagnostics page over in the UK. I guess would probably be your best bet. Let's see. Nick also asked, the PCV valve's not working. Can I find that on the data list? I'm not sure. On a mechanical PCV valve, that's going to be pretty hard to come by. There may be some electronic PCV systems out there that I haven't really looked into very much, but there could be data points for that. Thank you very much for that. And then thank you, Brian, for the checking in there as well. Holy cow, the questions are coming in like crazy on Zoom now. So let's see. Thomas, thanks. Great. So we'll see you 2 weeks in a row there, Thomas. Gerardo, thank you very much. Appreciate you joining us tonight. Glad you like the classes. Ron, thanks very much. Thanks for checking in there. Always glad to have you in class as well. So with that, looks like we've cleared the board on both sides. Thanks everyone for joining me. Let me go forward here a little bit. Thank you very much for taking a little bit of time out of your busy week. I'm sure everybody's having a hectic time right now, just with the end of summer and all that. And everybody's getting their cars ready for bringing the kids to school or something like that. And thank you very much for taking time out of your day, your evening, whenever it happens to be, wherever you are. Definitely appreciate your continued support and watching these classes. And hopefully we learn a little something along the way. So thank you very much. Enjoy the rest of your week. Enjoy the weekend. Hopefully we'll see you next week for beginning of EVAP testing, and take care of yourselves. Have a good night.